Welcome to Study Loop.
Hi friends, here it is given that the flywheel of an automobile engine which is rigidly attached to the crankshaft is equivalent to 400 millimeter diameter. So diameter is given 400 millimeter and of thickness 15 millimeter steel plate. Calculate the couple exerted by the flywheel on the horizontal crankshaft. So we have to calculate couple exerted by the flywheel on the horizontal crankshaft as the automobile travels around the unknown curve of radius to travel curved paths of radius 200 meter with speed 90 km per hour with flywheel rotating with angular velocity of 2700 rpm. First case, rear wheel drive with engine mounted longitudinally. Second, front wheel mounted transversely. So it is mounted longitudinally and it is mounted transversely. Density of steel is given 786 kg per meter cube. Let us start solving it. Let x-axis be a horizontal axis along the engine mounting, that is longitudinally, that is longitudinally for rear wheel drive. And transversely for front wheel. So that we have assumed. The angular velocity of automobile omega 2 having the magnitude v upon r. Speed is given 90 km per hour. If we use in meter, so 5 by 18, and the radius is given 200 meter. So its angular velocity will be 0.125 radian per second along y-axis, that is j cap we are writing. Angular velocity of flywheel relative to automobile. Omega 1 is equal to, and omega 1 is given 2700 rpm. So in radian we can write it so after calculation you will get this value to be 282.74 radian per second. Angular momentum of the flywheel about the center of mass would be Ix omega 1 I cap plus I by omega by y2 j cap. Angular velocity of reference frame gx by z omega is equal to omega 2 j cap. So rate of change of angular momentum of the flywheel, rate of change of momentum of the center of mass in reference frame plus omega cross Hg. Since it is rotating with constant angular velocity, so alpha is 0, omega is omega 2 j cap cross Ix omega 1 I cap plus Iy omega 2 j cap. So rate of change of angular momentum of the flywheel we will get minus Ix omega 1 omega 2 k cap. couple exerted by the shaft on the flywheel. M is equal to minus Ix omega 1 omega 2 k cap. So couple exerted by the flywheel on the shaft, they will equal and opposite. M dash will be equal to negative of M, that is Ix omega 1 omega 2 k cap. Now we have to calculate the mass of the flywheel, volume into density. So rho pi d square by 4 into thickness. Density is given 7860. Pi is 3.14. Diameter is given 400 millimeter, that is 0.4 meter. Thickness is given 15 millimeter, that is 0.015. This is not rho pi d square by 4. So it's divided by 4. So on solving it, mass of the flywheel we will get 14.816 kg. Since it is a circular pill, so its moment of inertia will be mr square by 2. Mass is 14.816. Radius, 200 millimeters, so it can be written as 0.2 kg meter square. You will get 0.29632 kg meter square. Now you can find m dash using equation 2 m dash. So m dash will be Ix, that is 0.29632 omega 1 282.74 into 0.125 k cap. So it would be 10.47 Newton meter k cap. So here you may say magnitude of couple for rear wheel to drive 10.47 Newton into meter. B part. For front wheel drive, magnitude of couple for front wheel drive will be same. That's all for it. Thanks for watching it.